Hello students, welcome to my YouTube channel. In this video lecture, I am going to solve all the questions from Keith Williams Radio Navigation, chapter name Radar Theory. Okay, so I have marked important points from this chapter, that is basic radar principles from Oxford Radio Nav book. Do watch that video lecture, mark the important points. I have also explained the concept while marking the important points. In this lecture, I am going to solve all the theoretical questions, MCQ questions from Keith Williams Radio Nav book related to that chapter from Oxford only, basic radar principles. Here the name of the chapter is radar theory. The concept is the same. So in the previous video lecture, I solved the first 10 questions. In this, I am going to solve the next 10 questions. But before solving the new questions, there is one correction that I want to make. In the previous video lecture, I said the effective range. In order to double the range of a primary radar, you have to increase the power output by a factor of 4. It's not 4, it is 16. In case of primary radar, it is 16. The answer will be delta, not Bravo, which I marked earlier previously. So the correct answer is 16. So make that correction, and now let's proceed to new question. Question 11. In relation to radar systems that use pulse technology, the pulse recurrence rate signifies what? What is the significance of pulse recurrence rate? So pulse recurrence rate means number of pulses per second, delay after which process restarts, that is flyback. That is called flyback. Okay, delay after which the process restarts is flyback. The number of cycles per second, ratio of pulse period to pulse width. So the correct answer will be option number A. Number of pulses that you are transmitting per second. Okay, that is pulse recurrence rate. Next, question number 12. In a primary radar using pulse technique, pulse length determines what? Target discrimination, maximum range, minimum range, beam width. Okay, so using pulse length determines minimum measurable range. Very important. In the previous lecture I have explained this in detail, that minimum range is determined by your pulse width or pulse length measured in microseconds. Maximum range is determined by your pulse recurrence frequency. Okay, so it's determined by pulse recurrence frequency. Beam width determines your azimuth resolution. Azimuth resolution. Next, question 13. In a primary radar using pulse technique, pulse recurrence frequency or pulse recurrence rate determines what? Similar, same question. So pulse recurrence frequency or pulse recurrence rate will determine your maximum range. Maximum range. Option A is the correct option. Minimum range determined by your pulse width. Beam width determines your azimuth resolution. Target resolution is nothing but target discrimination is nothing but radial resolution, which is determined by half the pulse width, and your beam width. A narrow beam width is required for azimuth resolution. Next, question 14. In a primary radar using pulse technique, the ability to discriminate between targets in azimuth is a factor of what? It is a factor of what? So that is pulse beam width. Now what is azimuth discrimination? So let's say this is your transmitter on the ground and here is your aircraft. There are two aircrafts here. Okay. There are two aircraft in the air. So the beam width, that is, or the radio beam which will be transmitted, will be something like this. Okay, so this beam that is radio beam will be transmitted from the transmitter. It will go to these two targets. Okay, and the indication will be shown on the ATC radar controller. So what radar controller will see is that instead of seeing these two separate aircraft, he will see both aircraft as one. Okay, both aircraft as one dot or one radar rectangle blip. Okay, on his radar screen. So in order to discriminate between these two aircraft or the targets should be located outside the beam width. Should be located outside the beam width. Okay, if they are located on the beam width or inside the beam width, the indication on the ATC radar controller will appear as one. Both aircraft will appear as one target. Okay, which is not right. So in order to get resolution, meaning proper differentiation between these two aircraft, they must be outside the beam width. And therefore, we always say that in order to get a proper target discrimination, we must have narrow beam width. Narrow means very thin in size or small in size. This narrow beam width, so that all aircraft automatically fall outside this beam width, outside the scope of the beam width. Okay, so remember, azimuth resolution is beam width and radial resolution. It is determined by pulse width. It is determined by half. It is determined by half the pulse width. Okay, this is very important. Half the pulse width. Next, which of the following radar equipments operate by means of pulse technique? Aerodrome surface movement radar, yes. So, operate in the frequency band of super high frequency. Airborne weather radar, yes, super high frequency. Secondary radar, yes, super high frequency. Aerodrome surveillance approach radar. Okay, so again, that is also based on pulse by means of pulse technique. So all these four equipments operate on the basis of pulses, radio pulses. So the correct answer will be 1, 2, 3 and 4. Option A. Assuming sufficient transmission power, the maximum range of a ground radar, okay, range, with a pulse repetition frequency of 450 pulses per second, speed is given is what? So use the formula I gave in the previous video lecture. Range is equal to speed of light divided by 2 into PRF, frequency. All the units must be SI units. Okay. Substitute the values. Range will be equal to speed of light 3 into 10 raised to 8, or speed of radio wave 3 into 10 raised to 8 meter per second. 2 multiplied by frequency. What is frequency here? It is 450 pulses per second. Right. So 2 into 450 is 900. 3 divided by 900 is 3.33 into 10 raised to minus 3 into 10 raised to 8 meter. This is equal to 3.33 into 10 raised to 5 meter. Now convert this into kilometer. So 3.33 into 10 raised to 2 into 10 raised to 3 kilometer. So in terms of kilometer, the value will be 333 kilometers. Multiply this 10 raised to 2, you will get 333. 10 raised to 3 is kilometer. 1 kilometer is 1000 meter. 10 raised to 3. Convert this into nautical miles. So 333 divided by 1.85 is 180 nautical miles. So select any option which has any of this value. 3.33 into 10 raised to 5 meter, 333 kilometer, 180 nautical miles. So any option which contains any of this value. Question number 17. A radar facility transmitting at a pulse frequency of 1500 pulses per second will have maximum range of how much? So same formula, range is equal to C, speed of light into 2 into frequency. So range will be 3 into 10 raised to 8 meter per second divided by 2 into 1500 pulses per second. So 2 into 1500 is 3000. 3 divided by 3000 is 1 into 10 raised to minus 3. So 10 raised to minus 3 into 10 raised to 8 is 10 raised to 5 meter. In terms of kilometer, it will be 100 kilometer, and 100 divided by 1.85 will be 54 nautical miles. Okay, so this should be your answer, 54 miles or 100 kilometer. Next, question number 18. Frequency is given to you. What will be the range? So range will be again C divided by 2 into frequency. So 3 into 10 raised to 8 meter per second divided by 2 into 1200 pulses per second. So 2 into 1200 is 2400. 3 divided by 2400 will be 1.25 into 10 raised to minus 3 into 10 raised to 8 meter. So that is equal to 1.25 into 10 raised to 5 meter, or 125 kilometer, or 125 divided by 1.85, that is 67.5 nautical miles. Simple. Next. Question 19. Aircraft surface movement radar operates on frequencies in dash band, employing or using an antenna that rotates at dash revolutions per minute. It is dash possible to determine the type of aircraft from the return on the radar screen. Okay, so aircraft surface movement radar operates on frequencies in the band of super high frequency. So option A and option delta eliminated. Next, the antenna will rotate at what rate? It will rotate at a rate of 60 revolutions per minute. So option Bravo is the correct option. And sometimes it is possible to determine the type of aircraft. So whatever indication aircraft ATC controller gets on its screen, looking at that indication, okay, representation of the target on the screen, ATC is able to determine the type of aircraft from that indication. Okay, because aircraft surface movement radar operate in the super high frequency band. That means the wavelengths are in terms of centimeter. Okay, very short, very small wavelengths in terms of centimeter, and therefore the target that is shown on the ATC radar screen is very accurate. The resolution is very intense. From that you can see the aircraft, the position of aircraft, their movements, and sometimes in favorable atmospheric conditions, you can also figure out the type of aircraft that is moving on the taxiway or located at the ramp. Okay, so that is the advantage of aircraft surface movement radar. Okay, the range of this radar is going to be short range, very short range, limited to airport environment only, and it is best used in terms of in case when atmospheric conditions produce low visibility. Okay, so in low visibility conditions, ATC controller will not be able to spot aircraft on the taxiways, runways, parking area, okay, from its ATC tower. So in that case, this radar can be used to properly navigate, control, monitor all aircraft on the runways, taxiways, apron, etc. So this is particularly useful at large airports, large busy airports. Next, question number 20. Range is given to you. You have to find out pulse repetition frequency if the range is 50 nautical miles. So range is equal to speed of light divided by 2 into frequency. Now frequency is equal to C divided by 2 into range. Everything in SI units. So speed will be 3 into 10 raised to 8 meter per second. Range will be 50 nautical miles. Convert this 50 nautical miles into corresponding meter. So first multiply by 1.85 to make it kilometer. Then multiply by 1000 or 10 raised to 3 to make it meters. Now the units in the numerator are equal to units in the denominator. Both are at a par with each other. So this will be 3 into 10 raised to 4 multiplied divided by 2 into 5 into 1.85. So frequency will be equal to 3 divided by 18.5 into 10 raised to 4. So 3 divided by 18.5 is 0.162 into 10 raised to 4, that is will be equal to 1620 or 1620 pulses per second. 1620 pulses per second. So I'll stop here. We will do the next 10 questions in the next video lecture. I hope you have understood all the 10 questions that I have done in this particular video lecture. Practice the numericals, very important. They will get asked in your CPL, ATPL exams, even airline exams. So practice them a lot from Oxford textbook and Keith Williams also. Do subscribe to this channel if you haven't yet and share this video with your friends please. I'll see you in my next video lecture. Till then, all the best. Take care.